Hey you guys, so here is what is this, notes number 6? I lose count. But here's our FLT. Go ahead and write it down. Press play when you're ready. So given a power series in summation form, you're going to know how and when to apply the alternating series test and the ratio test, okay? So just to recap real quick, where is it? Okay. So you guys have this convenient worksheet that I made here, okay? So just recall real quick, we had the nth term test or the divergence test to get rid of all the easy, all the series that are diverging. Get rid of all the easy ones that don't converge, right? And then we had the geometric series test, where if you have something to the nth power, you would probably use the geometric series test. If you had n as a base, most likely you would use p series. Integral test we'll talk about later. It's actually not that bad, but we'll talk about later. And then in the last lesson, you guys have the direct comparison test and the limit comparison test. So when certain summations or certain power series didn't look exactly like a p series or a geometric series, we could actually compare it in two different ways, by directly comparing it or by using a limit comparison. So today we're going over the last two, okay? Now, recently, College Board decided to omit the root test, which was easy, but that's just one less thing that you guys have to worry about. So we're going over the alternating series test and the ratio test. Okay, so here we go. This right here is the formal definition for an alternating series test. Okay, I'm going to break it down for you guys over here. So the alternating series test is basically this. When you have an alternating series, you use the alternating series test. So you guys are familiar that when series alternates, when certain terms alternate in signs, you occasionally run into this -1 to the nth power, some -1 to the something power. That is what makes it alternate. Okay? Now, you're going to learn that there are going to be some other ways to alternate a series, but we'll get to that. Okay? So basically what you do here is, first, if you have an alternating series, you're going to take the portion not including the alternating parts, so just your b sub n, so everything except the -1 to the, and you take the limit as n goes to infinity. All right? Two things are going to happen here. It either comes out to 0, which is what you want, or it doesn't come out to 0. So it takes a little bit of practice for you to memorize here, okay? But it will converge if the limit comes out to 0. All right? If it doesn't come out to 0, it will diverge. All right? So here I wrote for the notes, when you have -1 as a base, that's a big indicator that you should probably use the alternating series. And I say usually, not always, because it kind of depends on every single problem. All right? Now, I did make a note that sometimes the alternating piece can be disguised as a sine n pi or a cosine n pi, and even a negative number to the nth power. And I'll show you how we can run into that, okay? All right, so here we go. We have example 1 right here. Go ahead and write it down. Here's example 1. Okay? So, I might not mention it every time, but just understand that in my mind and in yours too, you should be running through all of the previous tests that we've been learning, okay? So I'm going to assume that we went through all of those tests before we resort to this next one here, okay? So I noticed that I have an alternating piece. negative 1 to the n plus 1. It doesn't matter what the exponent is, whether it's n or n minus 1 or n plus 1. That'll still cause your terms to be alternating. For instance, n starts at 1 here. So if n is 1, you're going to get something positive. And if n is 2, you're going to get something negative. And if n is 3, you're going to get something positive, and so forth. You notice that it alternates. Okay? So because that alternates, we're going to use the alternating series test. So we're going to take the limit as n goes to infinity, and we're only going to focus on everything except that alternating piece. So that's just going to be 1 over n. All right? Obviously, when n goes to infinity here, you're going to get 0. Denominator gets larger faster. So since it comes out to 0, we can make a conclusion here. Therefore, the series converges. How do we know that? By the alternating series test. Okay? Now, just a little tidbit. All right? There's another way for this specific example that you can explain it. Remember 1 over n. Remember 1 over n. Do you remember what that's called, right? Look back in your notes if you need to. This is called a harmonic series. And we know that a harmonic series diverges. Okay? Now, the other one, and the last one that you need to remember is, there's a special one here. Not exactly that, but notice how we have an alternating harmonic series. So the harmonic is the 1 over the n, and the alternating is the negative 1. So alternating harmonic series is commonly known to converge. So on your AP exam, you could easily say that this right here, the series converges, since it's an alternating harmonic series. So again, these two pop up a lot, so I encourage you to just remember it. Harmonic series diverges, alternating harmonic series converges, okay? All right, let's try a couple more. So alternating harmonic, you're taking the limit as n goes to infinity. What you're hoping for is for the limit to come out to 0, because that's where it'll converge, okay? Here's part B. Write it down. Now, it's not too obvious that this is an alternating piece or alternating series, so let me show you here. This is the same thing as n over negative 1 times 2 quantity to the n minus 1. So sometimes, as you've seen in previous problems, you got to rewrite it, okay? So this right here is the same thing as the summation of n over negative 1 to the n minus 1 times 2 to the n minus 1. Okay? That's just the law of exponents, okay? So notice how we have an alternating piece. So we're going to use the alternating series test. So here we go. We're going to take the limit as n goes to infinity of everything except the alternating part. So that's just going to be n over 2 to the n minus 1. Okay? So you take the limit of everything except the alternating piece. Okay? So we have n at the top, 2 to the n at the bottom. Obviously, exponentials grow faster, so you know that this is going to come out to 0. But what does that mean? Therefore, the series converges by AST. All right. So again, as I've said in the previous lessons, it's easy to run your test. The challenge is knowing which test to run. Okay. Let's keep going. Here's another one. Here's part C. All right. So this is actually an alternating series, all right? So I wrote it in your notes there, but let me just show you. Cosine of n pi is actually an alternating factor there, okay? Here it states that n starts at 3 and then it keeps going. So let me write this out here. Okay? Cosine of 3 pi, so here's 1 pi, 2 pi, 3 pi. Cosine right there is -1. Okay, just look back at your unit circle if you guys need to, okay? So if I go to 4 pi, cosine of 4 pi is actually +1. And cosine of 5 pi is actually -1 again. So notice how this factor here actually causes it to alternate, okay? So it doesn't look like -1 to the something power. It's just disguised a little bit. So that is our alternating piece. So what we're going to do is we're going to take the limit of everything except that alternating piece. Now, that square root of n is below in the denominator, so it's actually going to be 1 over the square root of n. And what happens when n goes to infinity? Obviously, the bottom is going to get larger faster than the 1 at the top, so this comes out to 0. Therefore, the series converges. So the only way that it's going to diverge is if it doesn't come out to 0, okay? The series converges by AST. Okay, hopefully it's not that bad, right? All right, here's the last test, the ratio test. This is probably the most important one, only because this is a good chunk of your points on the BC exam. All right, so the ratio test, what you're going to do is you're going to create a ratio, and depending on what the limit comes out to, it will converge or diverge. Okay? Now, if it comes out exactly to a certain number, it's inconclusive and you got to use a different test. But this is a little bit tough to understand, so I broke it down for you guys over here. So let's take a look. The ratio test. So if you have, let's talk about the when, okay? I wrote it over here. So usually when you have factorials, or you have some type of constant to a power, like 2 to the n or 5 to the n. So if you're dealing with those type of exponentials or factorials, you're using the ratio test. And you'll get an idea of what I mean, okay? So basically what you do is, your a sub n is basically your general term, okay? You're going to put the a sub n plus 1 term at the top, and you're going to divide it by the original a sub n term with the absolute value bars. And then we're going to take some limit, all right? Now, if the limit comes out less than 1, we know it's going to converge. Greater than 1, diverge. If it comes out exactly to 1, you use the wrong test, okay? That sounds like a lot because I haven't shown you a problem yet, but you're going to see right now. Here we go. So here's our ratio test. Example 2. So while you write that down, notice how we have numbers to the nth power, right? So usually that's a telltale sign to use the ratio test. But so is the geometric series test, because that's when you have something to the nth power, right? But this definitely does not look like a geometric series test, because it's supposed to be, something to the nth power. So keep that in mind. So here's what you do. You take the limit as n goes to infinity, all right? And I'm going to tell you guys right now, this is the number one part that people forget. We're going to take the absolute value, okay? Don't forget that. A lot of people forget the absolute value of your a sub n is basically what you started with. That's going to go at the very bottom. 2 to the n over 3 to the n plus the 1. It goes undisturbed, okay? Now at the very top, you're going to plug in your a sub n plus 1 term. So what I mean by that is pretty much replace your n, every time you see an n, with an n plus 1. So this is going to be 2 to the n plus 1 over 3 to the n plus 1 plus 1. I'll color coordinate so you guys can see. That's all we're doing. You're replacing an n with an n plus 1. Okay? Now, I'm showing you all the steps, but I'll show you how to cut corners afterwards, okay? So now we have a fraction divided by another fraction. So what you can actually do here is you could actually jump to this step here if you wanted to. We're going to take the absolute value of 2 to the n plus 1 over 3 to the n plus 1 plus 1 times the reciprocal. Dividing a fraction is the same thing as multiplying by the reciprocal. 3 to the n plus 1 over 2 to the n. Don't forget your absolute value bars. Now here, this is where a lot of things go away. Okay? So take a look. Here, this 2 to the n plus 1. Let me do a quick sidebar with you guys before I come back to that problem, okay? X to the 4th times x squared is, by law of exponents, you add your exponents. And that's how we get x to the 6th, okay? So if I take a look at 2 to the n plus 1, and I want to go backwards, that's the same thing as 2 to the n times 2 to the 1st power. All right? I'm going to go ahead and change that. So that right there is going to be 2 to the n times 2 to the 1st. You could cross it out and write it up top if you want to. I wouldn't do that on an AP exam because it looks a little messy, but it's up to you. Okay. Now, same thing with this 3 to the n plus 1 down here. That's going to become 3 to the n times 3 to the 1st. Okay? Now, okay. Things start to cancel out. For instance, if you notice, I have a 2 to the n in the numerator and a 2 to the n in the denominator, so they cancel out. Those are factors, so I can cross those out. Now, some people would be very tempted to crossing out 3 to the n on the top and the bottom, but this plus 1 here prevents it from becoming a factor. So we actually can't cross that out. Okay? So, let's write down what we have left. We have the limit uh-oh. Am I crazy? Let's jump out of this. Let's try one more time. Oh no, what's happening? Okay, here we go. So we take the limit as n goes to infinity. Now we have 2 to the 1st times 3 to the n plus 1 all over 3 to the n times 3 to the 1st plus 1. Okay. Once you've reduced everything that you could reduce here, you want to see what's left, right? So remember, when n goes to infinity, all of these constants become irrelevant. They have little value. So let me just cover that up there. When n gets really large, where is it getting larger faster? So if you notice, they are both traveling at the same exponential speed. So we are actually going to look at the coefficients. So this here actually comes out to 2/3. All right, which is definitely less than 1. And if you go back to that chart, you're hoping for less than 1 because that tells you that the series converges. If it's greater than 1, you know it's going to diverge. If it's exactly 1, you chose the wrong test. All right, by ratio test. By the ratio test. Okay? Obviously, doing this for the first time, I'm going through it, but we're going to speed it up as we move forward here, okay? All right, here we go. Here's part B. Go ahead and write that down while I erase this here. Okay, so some telltale signs that we should probably use the ratio test. There are exponentials here, and also there are factorials. Okay? All right, here we go. So we're going to take the limit as n goes to infinity of the absolute value bars. Okay? Now, it's going to be the n plus 1 term divided by the nth term. But we know that dividing a fraction is the same thing as multiplying by the reciprocal. So I'm actually going to cheat a little bit so that I can write a little bit less. That's just going to be e to the n over n factorial. Make sure you understood what just happened there. And if you do, you too can do that step. All right? Okay, so here's another thing that you guys have to understand. Okay? So first, I know that e to the n plus 1 is the same thing as e to the n times e to the first power. Okay, what I haven't gone over is how factorials work. So let me get some space up here. Okay, if I told you guys 5 factorial, that means 5 times 4 times 3 times 2, all the way down till you get to 1. But another way to write this is, I could just do 5 times 4 factorial, and that would still mean the same thing. I could even do 5 times 4 times 3 factorial, right? So look, every number that you move forward with is subtracted by 1. So over here, we have an n plus 1 quantity factorial. Notice how the factorial is outside here, okay? So n plus 1 factorial is n plus 1 times 1 less would be n times 1 less would be n minus 1 times n minus 2, and it can go all day, right? Or I can be very strategic about where I stop. If you notice in the bottom right of this fraction here, I have an n factorial. So what I could do here is n plus 1 factorial could very well just be n plus 1 times n factorial. Okay, so it is a little bit of rewriting, but with practice, you guys will get it. Every student of mine that has ever taken BC got factorials very easily. So don't worry if you're not there yet, you will. You just need a little bit of exposure, that's all. So n plus 1 factorial is the same thing as n plus 1 times n factorial. Make sure that you're understanding that before you move on. Replay it if you have to. I strategically stop at n factorial because I noticed that there's another n factorial right there. Okay, so magical things happen here. I notice that e to the n cancels out because they're factors, and so does the n factorial. All right, so you will be doing a lot of that where things will reduce out. So we have the limit as n goes to infinity of, I have an n plus 1 left at the top, and I have a e to the first power at the bottom. Okay, now n is getting really large, so where does it get larger faster? Press play when you're ready. Now, it actually gets larger in the numerator here, okay? Now, n plus 1 is linear. Some people might argue that in the bottom it's exponential, but e to the first power is a constant. E to the first will always be e no matter what. Now, if it was e to the n, that is a different story, okay? So, here we know that if the top gets larger, it just goes to infinity. So the limit here does not exist. But more importantly, it does not come out to 0. So what does that mean? Therefore, the series diverges by ratio test. Okay? Let's do as many as we can so you guys get exposure. Here we go. Here's part C. Try that one, go as far as you can, and then press play when you're ready, okay? Okay, here, I'm going to take the limit as n goes to infinity of the absolute value of the a sub nth term, a sub n plus 1 term, divided by the a sub n term, or multiplying by its reciprocal. Okay? I know by now that this is 2 to the n times 2 to the first, and n plus 1 factorial is the same thing as n plus 1 times n factorial. And then I noticed that 2 to the n cancels out, so does the n factorial, and I'm going to be left with the limit as n goes to infinity of the absolute value of 2 to the first power over n plus 1. All right? When n gets really large, this sucker is going to go to 0. Okay? Therefore, we know the series converges by ratio test. Okay, so we're moving a little bit quicker. Don't worry about speed yet. Okay? Replay it if you need to. Here's part D. Okay, telltale signs. There's exponential functions here. All right, so we're going to try that out. Press play whenever you're ready, but do try this out on your own. Here we have the limit as n goes to infinity. We're going to take the absolute value. First, we're going to plug in our n plus 1 term. So that's going to be n plus 1 squared times 2 to the n plus 1 all over 3 to the n plus 1 times, or divided by, the original general term, or the reciprocal if we multiply it. Okay, now some of you are wondering, well, couldn't I have just written n plus 2? Absolutely, but there are some cases where it's a little bit tricky, so I always write it out first, okay? All right, here we go. Let's clean this up a little bit. I noticed that 3 to the n plus 1 is the same thing as 3 to the n times 3 to the first. This right here is the same thing as 2 to the n times 2 squared. Down here, that's the same thing as 2 to the n times 2 to the first. And that's about it. Okay, let's take a look at what goes away. I noticed that 2 to the n will go away. I have 2 squared at the top and 2 to the first at the bottom. So I know that there's going to be one remaining 2 left over. 3 to the n's go away. Now, n plus 1 quantity squared and n squared cannot cancel out because they're not factors, okay? So I'm going to write it out. What do I have left? If you can't tell, you got to be really organized here, okay? So color coordinate if that helps you. It's going to be the absolute value of, I have a 2 at the top along with a n plus 1 quantity squared all over. I have a 3 to the first power and an n squared there. I think I have everything. Okay, so as n goes to infinity, what's going to happen here? Press play whenever you're ready, okay? You should get 2/3, all right? N plus 1 squared, the largest term you're going to have there is the n squared. Down below, we have another n squared. So we look at the coefficients. Now, the other two terms that we didn't talk about in here, if you were to expand, does not have a degree of 2. It's actually lesser, so they become obsolete as well. All right. But more importantly, 2/3 implies that it's definitely not 0. So what does that mean? The series diverges by the ratio test. Wait, hold on. I think I got that wrong. I'm thinking of the alternating series test. You guys probably think I'm crazy right now. All right, let me go back. Let me double check. We're looking for less than 1. Why didn't you guys say anything? Obviously you can't because it's a video. All right, so let's take a look at the ratio test. The first one came out to 2/3, which is less than 1, so we know that that converges. This right here came out to infinity. Ooh, okay. Mr. Lee made a boo-boo. This is definitely larger than 1 because infinity does not exist. Infinity is definitely larger than 1, so we know it diverges. Okay. 0 here is definitely less than 1, so we know it converges. And 2/3, oh, not that bad. But hopefully I didn't confuse you guys. 2/3 is definitely less than 1, so we know it converges. Whoops. By the ratio test. Okay. I would definitely pause here and go back in my notes just to make sure. I don't have that those values in front of me, so my bad. Let's keep going. Here's part E. Okay. So here, let's run the ratio test. Okay. The limit as n goes to infinity, absolute value of the n plus 1 term, so that's -1 to the n plus 1, square root of n plus 1, all over n plus 1 plus 1. Okay. We divide it by the original general term, or we multiply by the reciprocal, which is n plus 1, all over -1 to the n times the square root of n. Okay, so a few things. The absolute values actually gets rid of the negative factors. So the absolute values here actually do take care of that one and that one because it always has to come out positive. Okay? So you're really looking at this. We have the square root of n plus 1 times n plus 1 all over n plus 2 times the square root of n as n goes to infinity. This one is actually easier than it looks. So take a look. The square root of n plus 1 and the square root of n, when n gets really large, they're traveling at the same speed. So it's like a wash here, okay? And n plus 1 and n plus 2, even though the 1 and the 2 don't matter, they're traveling at the same linear speed. So if you notice, the numerator and the denominator, even if you were to multiply that out, they're going to travel at the same speed, meaning that this will come out to exactly 1, which means that you've used the wrong test. So this is what I mean, you guys. If I were to just give you this problem here, what test would you have ran? Okay, you got your divergence, geo, p-series, direct comparison, limit comparison, alternating series, right? So you should have remembered that -1 to the n is actually an alternating piece. So it would have been better if we used the alternating series. So here we go. If I use the alternating series, I would have to take the limit as n goes to infinity of the piece that doesn't include the alternating part. Okay? When n gets really large here, okay, it's getting larger in the denominator because the denominator has a larger degree. The square root of n has a degree of 1/2, and n plus 1 has a degree of 1. So obviously 1 is larger than 1/2. So since the denominator is getting larger faster, we get 0. Okay? 0 is definitely less than 1. I'm confusing these two. The limit comes out to 0. Therefore, by the alternating series test, we know that this will converge. I put less than 1 because I thought we were running the ratio test, but you could see how confusing it can be if you're not focusing on the right test, okay? So there you go. Okay? That's pretty much it. Practice it. Again, I know you're focusing on these two tests for your assignment, but also keep the other ones in the back of your mind there, okay? As you can see, for this one here, there's a little bit of algebra, so you might have to rewrite some things, but it's actually not that bad because a bunch of things just cancel out and you're just analyzing at the very end. Okay? That's it.